Hello everyone, my name is Bhavesh Kumar and I'm with Early Educations, and today we'll be going into our third session of Intro to Computer Science. In today's lesson, we'll cover a little bit about branching and iteration. We'll talk about casting, how to change one type to another, and we'll talk about different types of functions, what are functions and how people use it in these days to make their programs efficient. By now, you should already understand basic concepts like algorithms, casting, input-output, and etc. Today, we're going to create a calculator in order for you to better understand some of the syntax that I'll be going over today. Now, while we're creating any program at all, the first thing we need to consider is how we're going to go through creating the project. This is called pseudocode. Pseudocode. Whenever you write a Python script, you need to learn how to write a pseudocode first. So if I were to write a pseudocode about how I were going to program a calculator, it would go something like this. I would start with take first input, as we need one, take first input and second input, as we need two inputs, which represent the numbers that we're going to be doing operations with. Int type. Then we would take an operator. Then we would go through the process and see if the operator is this plus sign over here. Then we would add the two numbers. Now, if this operator were a negative symbol, then we would subtract the two numbers. Else, if the operator was a multiplication, then we'd multiply the two numbers together. And finally, else, that means the only other option it could have been would be the division. We would divide. Now this makes sense in human life, but some of these options make no sense at all. For example, every time we inputted in the last session, we noticed that our type was always a string integer. Now, how are we to convert that string integer into an integer type variable so that we can actually do these operations such as adding, subtracting, multiplying, and dividing? That's where casting comes in. So as you know, casting in a sense means to convert a variable of data type A into data type B. If I were to show you this in practical life, I'd go to terminal and I'd do something like this in a Python script. So if I were to create a variable called num equals to, and this is in quotation marks, 3, which tells us that this number variable should be a string variable. So if we write type num, we can see that it's a string variable. Now, if we want to convert this into an integer type, it's completely simple, and all we need to do is write num equals to int, that is where we're casting, this is how we cast, int num. So the basic rule of casting would be to write what type we are casting to. For example, here we're casting to int, and then inside the parentheses we would write the variable that we want to cast that number into. Now, a lot of the times when you're casting integers into floats or floats into integers or casting data type A into data type B, you're bound to lose some information. For example, if I were to have a variable called num2, which equals 13.798, and if I were to write num2 equals int num2. So if I were to cast this into an integer data type, then I'd lose everything after the 13th point, because as you recall, an int doesn't have a decimal point after it. So a lot of the times when you're casting, you're using abundant amount of information. And that's why it's not healthy to always cast, and that's why it's unhealthy to always cast all data types into integer. They're data types like floats created for a reason, and we should use them for that reason alone. Now, if we take a second look into our pseudocode, we notice these couple of blocks of text that we have no idea how to code into our actual program. These blocks of codes where we iterate and figure out if this is the path we want to take, or if is this the path we want to take. You can imagine these blocks of code like a fork on a road where you have to choose either or. If one condition is met, I go to the left side of the road, or if the other condition is met, I would go to the right side of the road. This, in computer science, is called if-else statement, conditional statements. Now, these conditional statements syntax are as follows: if condition colon expression with an indentation below. Indentation in the programming language of Python represents any block of code that is represented under a condition statement. It could be a while loop, a for loop, or any function at all, but the indentation represents something being inside or being done after this condition is met, true or not. So these are made for the logic unit in the computer to better distinguish and for our human eye to better understand and make sense out of the code. Some things to remember when you're writing these conditional statements are to remember that there are colons after every single conditional. This is a major beginner mistake that people forget to put these colons in, or if you're learning another programming language, people forget to put semicolons after their expressions. If the expression is not indented, your computer will not be able to understand which expression goes underneath which condition. So make sure that your expressions are always indented. Now, when you're writing an if-else statement, you don't need this else or elif statements in order for the if statement to work. You could just write an if statement and write the condition and expression underneath it without including an else statement or an elif statement. Now, this elif statement is short for else if. So that would be adding a third roadblock or a fourth roadblock. You should also consider that this else statement has no condition, and the computer does not want it to have a condition at all. This would be anything that does not fit any of the other conditions so far. Now that we've learned this, we should also take a look at a major concept that we will use in our calculator script. These are called functions. Functions are an abstraction created to make coding more efficient by establishing a set process which can be used anywhere in the code. So if I want to use this function of adding again and again, I can create and establish a function early on which says give it two numbers and automatically returns a value, which is the addition of these two statements. So you don't have to copy the snippet of code again and again throughout your script. Now let's start creating our actual calculator, shall we? So if we take a look back at what our pseudocode says, our pseudocode first asks us to take two inputs, the first number and the second number. In order to do that, we would first assign them to a variable. So I would write num1 equal to input, and here I would enter first number, and I would do the same with num2, where I would write input and write the parameter, enter second number. Now, as you remember, we also need to cast these. And now there are two ways to do this. The first is you could take num1 equals int and cast them with 2 extra lines of code where I would write num1. Or I could do something where this casting is overlapping the input function itself. So I would write int, and inside parentheses, I would write the value that we get from this input. So both do the same thing, but in this format, we're actually reducing 2 extra lines of code by putting them all into one jumbled mess. Now, if you want to do it this way, it's personal preference, and I like to do it this way, but a lot of other people might like to do it, and might like to do it with 2 extra lines of code to maintain a clear sense of what they're trying to do with every step of the way. Now that we've taken 2 inputs in, we also need to take an operator. Now I would write something like OP to represent operator. And then since we don't need to cast this input, we just write input. And here we just write operator. And just like that, we have our 3 functions. Now we need to create those blocks of code that we had created while we were writing the pseudocode. So we would write if op equal to. Last week we discussed this double equal to represents the condition. Does this equal to this value? Does A equal to B? So we would write does operator equal to plus, and here remember the colon. We write colon, and then we would just say add num1 comma num2. Now here we could do something where we actually manually add these 2 numbers together, but for the sake of this lesson where we're trying to incorporate functions itself, I'm just going to write add to tell me later on that I want to write a function that would add the 2 numbers together. And then I would write elif operator equal to minus, and then I would write sub in the sense to write subtract num1 comma num2. And I would do this for all the possible I would do this for all the possible operations we could have. And here, for the else statement, where the operation is none of the above, we would just print and say we could not find, unable to do operation. Okay, so now we have to create our functions. Like I mentioned before, the syntax to creating a function is simple. We write def to indicate we're defining a function. We write the name, add, and here we write 2 parenthetical values, which indicate that the 2 values a person should include when they're calling upon this function. Now we could name this anything we want. For example, we can name it val1 and val2, but basically behind the scene what it's doing is it's taking this number when the function is called upon. It's taking whatever number is in the place value first, num1, and it's assigning that to val1. So while we're writing this definition, the notion of num1 and num2, these two variables don't exist at all. Only val1 and val2 exist. So we would refer to these two values using these names instead of the names we're giving them when we're running the function. Okay, so we would write answer equals val1 plus val2. And this is an important part of every function, is the return statement, where you return an answer or return whatever you did with the function to the user itself. So when I write answer equals to this operation itself, it's telling me whatever this function returns, you need to put that into this answer variable. Return statements are not necessary when you're creating a function, but they should be included to tell the user that this is what you get when you run the function. Now if we do this, now we have to do this for every other function we wrote. So add, then the other one is sub to represent subtraction, where we just subtract the two, and then there's mult, where we would multiply the two, and there's div, where we would divide the two. We also need to store these values, so we would write answer equals this, answer equals this, answer equals this. Now, we also assign answer equals to 0 at the top here, because here, what we're doing is we're printing answer by itself. Now, in the case that whatever we put in the operator was none of the above, then we would get the answer of 0. That's why we need to create this variable outside of the if loop so that you can access it outside of the if loop. So now if we run this function, we can see if I enter 12 and if I enter 9 and I write plus, it adds them together and gives me the result. If I enter 200, if I enter a huge number and I enter 1 and I divide them, give me the result. That's it for this course. I hope you enjoyed. Please make sure to like, subscribe to Early Educators.